to work with you all and get a chance to present. We'll get started right here. You can see my screen, I assume.
Yes, I can see it.
Good deal. All right. Well, today I just wanted to take a little time and talk to you about Azure Databricks in the modern data warehouse. So we're going to talk about a couple of these topics in some depth because they interrelate at this juncture. So let's get started. About me, I'm just a lowly technologist, been bouncing around data centers and technology for quite a while. I'm a principal data architect for 3Cloud. We've got a few of us out here. It's great to have some good company, smart people. I've been a Microsoft technical architect for data and AI and the MTCs. So I may know you, may have met you in the past, and it'd be great. I worked at Kennedy Space Center years ago. I've been consulting for many years. 3Cloud is my home and my family here. As you saw, they bought Pragmatic Works, so it was great to come home. And then many others. I like to be involved in the SQL Server community a lot. That's where I spent many of my years. And of course, I love Apache Spark, Raspberry Pi, and a few other things along the way. But anyway, it's good to hopefully get to meet some kindred spirits. You can see up there in the sort of top picture with me holding the little yellow stuffed animal. That is the actual Hadoop, and that's Doug Cutting. So you've been at Hadoop, so neat. So one thing we have to do when we start talking about Databricks, at least from my perspective, is I come with a little bit of perspective of time that sometimes people may not have. And as you'll see, we're going to revisit 2010 briefly. So we'll even go back a little further since there's some other things that set the stage for that. It's 2008. Hadoop has been out 2 years, right? With my friend there, Doug. President Obama's been elected to his first term. We got our first iPhone. Twitter just came out. Chrome just released. Then there were a bunch of things that went on with Hadoop. As you can see at the bottom, we had Hive and HBase and Pig. Many of you may have tried working with those different tool sets and had varying degrees of success with them. They were great. They were fantastic in their day. So in 2010, data warehousing itself could be a struggle. There was a lot to do, and one of those struggles was we were taking in more and more data at a faster and faster rate. It was all hands on deck for that. As you can see, it gets better. You can see to 2010, we got nice calm waters. Boat's getting smaller, but hey. But also, since it's 2010, analytics data is eating into budgets. It's huge. We're ingesting data at an enormous rate. Performance is getting killed. People are staying up late working on servers and trying to keep things running. So it's a different day for sure. So meanwhile, in 2010, we had, and we in the Microsoft stack world, most of us had our servers and whatnot were all either on premises, hopefully you didn't, or co-located at a data center, that you didn't own, and you just borrowed space from or rented space from, or managed in a full data center where someone else did all the work, right? They looked after the server, they responded to alerts, they did the patching. So that's what I'm referring to. SQL Server 2008 R2 was out. Was a great product. Spent a lot of hours in front of that one. And often these things were organized in the Kimball star schema method. Ralph Kimball over there in Chicago and his team, the Kimball University, came out with a sort of idea of unfolding all these relationships from all these third normal form databases and flattening out those hierarchies and making it easier to work with analytics and data. We had analysis services, still do today. People were doing OLAP and cubes. We didn't, I don't believe back then had any form of tabular. We might have been on that cusp, but most people were doing cubes at that time. Integration services was the de facto way we tend to move data back and forth, do transformations, and basically do the good work of the care and feeding of a data warehouse. And of course, reporting services was everywhere. Most of us, may have written a few hundred or thousand reports for people using SSRS, which is, these days everybody refers to it as sort of a pixel perfect rendition of a report because it can be very accurate. I can remember having to write a report for a banking firm that had to be accurate because we were printing the micker, the magnetic ink at the bottom of a check. So everything had to be spot on to make that all work. So anyway, we did a lot with reporting services, and there were lots of war stories I'm sure many of you may know. At that same time, people were really getting hammered. I mean, the systems were just getting beat to pieces, and so some of that came from the fact that we were dealing with SMP architecture, right? Symmetrical multiprocessing was more what you have in a desktop today. If you're using a laptop computer, you're using SMP. It's got multiple cores, usually somewhere between 2 and 4. You may have more. And then, you've got a shared memory. Everything's attached to a bus that's common to all those things. And that's kind of the picture there on the left. And then there's this whole other idea that was being talked about a lot, and was not a new idea at that time either, which was massively parallel processing, MPP. And the idea there is we're taking individual computers and getting them to work together in an orchestrated way to solve a big problem. So, basically we'll call it the head node would take apart a problem and give node 1 a job to do, and node 2 a job to do, and node 3 a job to do. They would go away and go do their work and come back and then combine the results at the head node and present your answer. So that was one way we dealt with scalability problems, still do. MPP is still an important aspect, and we won't get too far into that today, but it is continued to be a part of the answer. So one of the problems in 2010 was that processors weren't particularly fast. They still aren't. We really haven't gained that much ground since then. We've kind of plateaued on the speed for all the knowledge of Moore's law and all those sort of things that some people may know about. But the workloads weren't often CPU bound. You could see that most of the problems were other places, and we had enough memory to cover a lot of what we were doing, but storage was awful. I mean, I worked on a lot of it, got certified on Hitachi Sands, and I worked a lot with the other brands as well. I had to do a lot more of that in my role. So, SQL Server lives, eats and breathes data by reading off disks. So the speed of that disk I/O is huge. So how fast it works is really dependent on that. Networks were another big problem. The networks weren't, you'd go in most customer sites and they would be dealing with a 1 gig network. Now 10 gigs was barely out by around that time, but nobody had it for the most part. And most people were still working on their antique switches and stuff they paid for the previous 10 years or something. So other people talked about Hadoop and NoSQL and whatnot, and they were saying, well, we don't need all these guarantees. You've got all these transactions, and these transactions take time, and they eat up a lot of disk space, and they chew up a lot of resources. That's Dr. Codd right there, the founder of the whole notion of the idea of blocks and third normal form and guarantees of consistency, of ACID consistency. If you're into data, you understand what that means. Yeah, that's my only tattoo. I'm just kidding, I didn't get a tattoo, but that is Dr. Codd. And that's why it says, "So help me Codd" at the bottom. So the interesting part about 2010 was this guy. He was a professor at UC Berkeley in the AmpLab project in 2009. His name is Matej Zaharia. Smart kid, very talented, very much in the same realm with Dr. Codd and many before him who were at that skill level, out that brilliant place that we all wish we were, or at least I do. So this guy, he not only looks like the original nerd, and he is when you see him on various videos and hear him, but what he really brought to this problem in 2010 was he realized that the problem wasn't all these things that people were attempting to solve, but what it really was disk I/O. We weren't getting disk performance we needed, and network capacity. Those two things were really killing any kinds of ideas of doing distributed computing, at least at the scale that we were hoping for. Because remember, we're taking in this massive amount of data, and so he came up with this idea to do an in-memory distributed framework that we now call Spark. And once he invented it, he pretty much handed it over to the open source community, to our good friends at Apache. It became what we call a top-level project. And so since then, we've had Spark in our world. So the reason that it's so fast is it's always in memory, right? So all of the stuff that we do in Spark is all in memory, which really helps these big data workload problems. And that's really, I want you to think of that as the focus of what we're going to talk about. We're going to get to the modern data warehouse part, but understanding how this fits together is huge, because back in the day, folks like myself worked with SQL Server, and we tried to do all kinds of strategies to get speed out of it, and similar things like Oracle and like even MySQL or Postgres. They were all out there then too. And it was a difficult thing to do. We were kind of limited by the hardware resources. And that's why Hadoop was starting to become very much part of the landscape. I myself went and spent many years chasing after that as a way to get scalability to SQL Server. We had ideas like federation, if you know what that means, where we could tie 5 or 6 or 10 SQL Server boxes in sort of a horizontal stripe and shard the data across those 10. But then, when you finally get to do that and you have the budget to do it, you also now have inherited another problem, which is, high availability. And what do you do when one of those boxes is down? It begets a new problem. So anyway, back to my point. This young guy here and his team did a phenomenal job, and it's been very much the seminal workload for this age, or this time, and so Spark is hugely important. And what he created in this thing, and he and the team, he gave us Spark SQL, which why force people to understand and have to do a lot of training when it comes to how to query this and how to make that work. So we got Spark SQL. We also got Spark Streaming. Streaming is a unique thing in world of technology, and it was the first time I'd worked with streaming was in Spark. And then MLive was huge. Most of us weren't dealing with machine learning and that type of thing, or at least I didn't know anybody doing it. My first experiences with machine learning were with MLive within Spark. And so it continues to build on that story today. Also, we had this thing called a graph database sort of thing, where you could relate different bits of information together in a kind of a unique and new, novel sort of way. We could show the relationships between things. And what I mean is, in fact, I've got a little demo. I can take us out and we can look at an example of it. But where I want to know, how does this person relate to that person and that organization and that country and all those things? Well, graph databases are great at this, and they're fast. But also, there's also this notion within that thing too of a true graph, more like just a UI that you can look at some results to. So that's kind of the Spark framework in a nutshell. His idea too, I thought was really interesting, was this idea of the RDDs. It's really a core concept in Spark, right? They're fault-tolerant data sets. So remember, we're spreading out the love. We're querying data, we're doing things, we're transforming it, and we're doing it in parallel. So we've got not one computer working on a problem with a data set. We may have copies of that data set scattered across 100 computers. So it has this notion of parallelization. And so it's supposed to be tough and capable no matter what, and fault tolerant and all those things. So it's an interesting idea. And one of the things I heard him talk about that I liked was that when he and the team started to build the Spark platform, he was kind of there was a short time where they tried to figure out, well, what language should this thing run, and they picked Scala. They didn't know Scala. He didn't know Scala, but it was currently being used a lot, I think, in the scientific communities. So I thought, all right, Scala. So they went down that road, which is why the Scala. And if you watch some of his YouTube videos and whatnot, presentations he's done, you'll hear about that. But I really enjoyed that, because the fact he didn't know the language didn't slow him down. I just went and used it anyway. So parallelization is the huge piece of this. You need to be able to either use an existing collection that you've created in your process, or reference one that's already been created. That may be sitting in a Hadoop cluster on HDFS or in HBase or something. So I thought that, for my part, I always thought that's an interesting idea, being able to reach across the ether sphere, if you will, and work directly with data sets that exist in a known shape, form, and status all the way across to another server. Anyway, so Matei Zaharia, when he does all those wonderful things, he founds Databricks, and then pretty much everything is unicorns and rainbows after that. And of course, luckily for us, Databricks joins the Azure platform in 2017. So we're all very happy for that. I know I am. I didn't draw these pictures, by the way, so I wish I had. I can't draw that well. So what I think about Databricks is they have a set of superpowers. The notebook experience that you'll see, or you may have already experienced, is really second to none. It's a really well thought out sort of web UI, which web is by itself is a little bit harder to do than anything to do with a local desktop machine, right? You have to think about different devices and how that might work. But the UI itself, in my opinion, is one of the best. It's easy to work with. It's easy to learn with. It's easy to bring new people on board. You can go from zero to building usable things right away. There's really very little friction. Has a huge community of users, and I think that's very important. I myself have benefited over the years of having a large community of people with me along for the journey. In SQL Server, for example, there's literally millions of us across the world, and we get together, we talk, we go into community groups, we share knowledge, That's a big thing. I also think that the Databricks folks are to be commended for making so many of their resources free or reduced cost so that you can learn, right? So, I mean, the barrier to entry isn't there. It really is up to you and your time and whatnot. So, I think that those are some really good pieces of this story. That not only is the architecture being superb and strategy using in memory to solve all these problems, superb, but also the fact that we have all these other things that really aren't part of technology per se, but they are a huge reason why that Azure Databricks is a win for our customers. So I can take a minute and do a drawing. Let me see what time is. I want to make sure I manage time better. What I wanted to do, I have a scan drawing, but I never like to use those as much. So if you'll humor me for a minute, I'm going to do this the old-fashioned way. I wish I was on my big computer, but I'm not, so you're gonna have to be patient. So when we started out in data warehouses, we had things like we had a single database, right? And out of that database, we wanted some things for reporting. So we created usually another database somewhere, and some of the tables and artifacts would go gingerly get dropped into this thing. And what would happen is reports would be coming off this side, right? So we didn't interrupt production, right? That was really kind of the beginning of this. And you later saw these things, the nascent sort of ODS, operational data store. I always think of that in this use case. Well, that wasn't really enough to answer questions, right? It was enough to tell me, here's a copy of the chart of accounts and all of the payment history and this and that from an accounting system. This we'll just say this is the ERP. But it wouldn't really tell you a lot of the story. So then came, things like, well, Ralph Kimball, I mentioned him earlier. So Ralph and his team, we developed what we call the star schema, right? Where we organized data and facts and dimensions, right? So here are the dimensions hanging off this fact table. Fact tables tend to be the things you can add, subtract, multiply, and divide, like sales for the day, for example. And so that is what we tend to think of as a data warehouse, right? We have organized fact tables. Usually there's more than one, is usually quite a few, and then dimension tables that describe the data. And what we're doing is we're flattening out the hierarchy so that for speed, but also usability, right? So we do that for things like the date dimensions, probably the biggest dimension, where we take a date and then we break it down in every way you can think. You can report on a date. And the reason we do that is if we have to do that kind of thing in code, it's expensive, it's slow, and it's also error prone. And with a date dimension, we can fold out for a single calendar date, what month is it in text? What month is it in numbers? What month is it in a date time data value? What season is it? And what quarter is it? All these things are attributes of that table. So it's phenomenal. It's a great strategy. If you ever get interested, go find the Data Warehouse Toolkit from Ralph and his team. They've semi-retired and they're still around, but the books are around and the ideas are around, the website's still up, and there are a lot of us who use it every day. And the reason that was important is that this is what I'll think of as the Data Warehouse 1, is the 2010 sort of era. And I know some of you may go back further and argue about that, but I think of that. And so to have a modern data warehouse, you had to have something different, right? So this is Data Warehouse 1, whereas modern data warehouse takes a little different sort of tack on things. We kind of know that scale is a problem. We know that the way we do things is a problem. And one of the things that makes it modern, let's just make a list here. What makes it modern? Modern is it's cloud. I think, most of us Mine have grown up in the data centers and had to do all the nasty, icky work, missing Christmas with the kids and staying up late at night and doing things. The truth is, we had to. There was no choice. Somebody had to do it. These days, we can do better things with our time, right? So we can go to the cloud, get the benefit of that. Someone else is doing it. On top of that, this is a big world, and we can get people to do it 24/7. We don't have to come into the data center in the morning to find out that a box of green bar has been spit out all over the floor because the printer jammed. So those are some of the things we used to deal with. So onto this, what other things make it modern is that we have better tools than we used to. So here we are. So now we have data's coming in over here, so this is back to our ERP. It could be your CRM. It could be a lot of different data sources on this side. But it also could be, these days, you could be getting, anything from JSON to XML feeds from somewhere else being dropped in a folder, Excel spreadsheets. It could be lots of things. And more as time has gone forward, it started to, these are what we think of as structured data, right? We know what the shape of that data is, what the data type should be, what the values should range at. So we have some pretty good clues about the data when we get it. But now we have this whole new thing, right? So we have things like pictures, right? So here's a picture with a sunny sky and all that, and then movies as well. And because a lot of these things are becoming data sources, as well as IoT. So we may have a whole bunch of sensors tied to our trucking system. And our job now is to take this sensor data that's flowing in and do something with it. So data's coming from a lot of different places than it used to. And so they're being in this, what we think of as a gather phase, right? In the gather phase, we gather all this data together, and then we usually have to do some type of transformation to it. And so we'll use, in Azure, we've got a couple choices. One of them is Azure Data Factory. I'm just going to abbreviate that here. But we could also be using Spark to do this. We could be using our friend at Databricks. Azure Databricks can do some of these jobs. So, depends on, what you have that you're attempting to do and what scale kind of decides your approach to this. Do I use Azure Data Factory? Well, I kind of like it. And by the way, it runs on Spark. So, it's just another example of why Spark is so important. But I could be doing it with Databricks. Or maybe I've decided, I love Databricks. All I want to do is I'm a notebook guy now, and everything is a notebook. So I would rather use this maybe to, Data Factory will move this from here to Azure Data Lake Store, which I'm going to abbreviate. And then my friend here at this Databricks notebook will pick up that data and do something with it, do some transformation step or whatever. And these things are not either or. You can execute them between them. So it could be a step in your pipeline. So as we go forward, these are design choices you may make. A lot of people like to just go from Data Factory to ADLS, and then they'll use Databricks, Azure Databricks, to do machine learning, or they might want to do it for the purposes of, because of the size of the data they have, maybe they want to use it for to do this gnarly transformation step they need to do. So, and it scales well and does that sort of thing well, so why not? So this is the gather phase, right? So we're gathering up all this data, and then as time goes on, we end up trying to do this store phase. The store phase is where we actually are storing the data to ADLS, or meaning Azure Data Lake Store, or to another database. It could be that Azure SQL databases where I want Data Factory's flow to send this curated, cleaned data over to my my reporting data warehouse that's sitting out here, and it's running on Azure SQL database and sitting out there in its star schema. So that's an approach, right? So I'm going to squish this down just a little so I can see better. So we go through that. Now down here in this IoT phase, I might have a product from Microsoft called IoT Hub out here. I can literally attach millions of sensors to this thing. And it's store and forward kind of technology where it can sit there and accumulate. And I can also pick it up with a streaming analytics job here. Well, I'm just going to abbreviate that, SA. The job will just basically read that, and then it can then do several things. It can do multiple things at the same time. It can do a cold path and send the data over to Azure Data Lake store, but it also could stream that data to Cosmos DB. There's my little Cosmos DB. That's a hot path, by the way. And there's also a streaming path that I might go to Power BI. So this is why this is modern data warehouse. We couldn't have done any of these things years ago. These are all new tools, new technologies, new approaches. And so with that in mind, I think I'll switch to my regularly scheduled program, and we'll start back there. And let's see here. Let's go back here. We'll go from here. So this is a pretty drawing of that thing. Don't want to take you down the rabbit hole too far. And you can see, there on the left, we have our sort of ingest, gather sort of phase. We're bringing data into this process. We're doing the store. And we have a lot of new discussion these days around Data Lake, which I know is a big part of our friends over at Databricks and other places. So it actually is another Apache project that's open source. So they're out there doing their good work. So then we have this prep and train phase, right? And this is really hugely important if you're into, particularly into data science. You can't just do machine learning on nasty data that shouldn't have been ingested, right? So this prep phase, we're going to clean the data. Let's just say it's IoT data. You see the sensor over on the top left. Well, those kinds of sensors spit tons of data. And oftentimes the sensors, it's not one sensor. Think of a weather station. Might have a dozen sensors, might have 2 dozen sensors. They don't bark at the same time. So I've got gaps in data. I'm missing time periods in the data, or I'm missing values for some of those sensors. So there's a lot of cleaning on time series data that has to happen to make it useful. And Spark and Databricks is excellent at that problem, where I can say, okay, here's a time slot. I want to find all the values I need for this time period. Let's say it's a 5-second period or 1 second period. Who's got the values I need? And then I'll find those. And then I'll say, all right, what's still missing? Well, I'm still missing this value, this value, and this value. I can go get them from the past and bring them forward. Those are imputed values, right? That's how I'm dealing with missing values and bring it in. And now I've got values for that time period. Now, if you think about that, first it sounds a little awkward when you're going around and making up data, but you're not. You really don't care at a weather station grain about anything more than every 15 minutes. So I want to know the latest temperature, humidity, whatnot for that 15-minute period. That's what I want to know. I don't care, the micro changes that could have happened somewhere along the way. All right, so and along with this, we have in this prep and train phase, we have good old data factory doing mapping data flows, all kinds of things, doing the transformation steps, and often these days we'll see our friend Synapse Analytics, which is an MPP solution, which we talked a little bit about that, massively parallel processing, got lots of history at Microsoft with the PDW and APS on premises or physical sort of appliances, which begat Azure SQL Data Warehouse, which then became Azure Synapse Analytics. And each step along the way, the Microsoft story has gotten richer and better. It's fantastic to work with. I advise you to get comfortable with it. It's phenomenal. It uses a lot of Spark to do its good work. Same thing as our friends at Azure Databricks, but also Spark clusters everywhere. And then of course, you see over there, we're taking Cosmos DB and the model and serve, and we're bringing it through to Azure Machine Learning. But these are just examples, right? Your workloads definitely will be different, and you'll find the path to what you are trying to do. But you can kind of see, you finally end up with Power BI, and you get a chance to do that sort of phase where the business doesn't care how we did any of this stuff. What they care about is the answers are correct and that they're dependable and that they're always there. And so they don't want to have to, suss out what a data model looks like. They want to know where the values are. So we give them that layer, and then surface that through like Power BI data sets, and then eventually to a Power BI report. So there's that's really it in a nutshell. And so you can see right in the heart of this diagram, where does Spark belong in Azure Databricks? Right there in that prep and train phase. Could use it along different areas of this whole thing. Could be back. Maybe we wouldn't even need Event Hub. Maybe we would stream straight to our friends at Spark at Databricks. So there are lots of ways to put these little building blocks together, and there's no single always right answer for any of it. But I will say that having Azure Databricks around has been a huge boon for me and people like me. All right, I'm going to have to probably pick it up a little bit, I'm afraid. So this is a big question. You got, of course, it's a fork in the road. When for the Azure Databricks? Well, and the reason that the when matters is think of the history. We needed a tool that could deal with data at scale, big data, lots of it. And so, Databricks provides that facility, and they do it through a fully managed Spark cluster and interactive workspaces, a pipeline scheduler, platform for building, Power Spark-based apps. So you get an entire platform. And part of the reason that's big is that if you've never managed a big data cluster, and I have done a few myself, I can tell you it's a lot of work. Like the last time I think I stood up a Hadoop cluster, it probably had over 80 YAML files. These are configuration files, as you can see over on the right. And they're everywhere. They control the behavior. They control how things work. Yes, Cloudera Manager, for example, takes away some of that burden, thankfully, and others, I'm sure. But the truth is, do you want to be in that business? And most people don't. They really don't. What they want to do is go out and do the good work that they do every day. So, as far as, open source and all those things that we are looking at here when we're talking about the foundations of Databricks and how it's open source and all that, but there's a lot of great history here for companies that do a great job of with open source products, inventing them and extending them, and then going on charging for support and helping you with your problems and helping you with engineering, all these things. And so there's a really great long history now that's come for some time now. All right. And then the workloads I mentioned earlier on. If you've got this mondo amount of data that needs to be mashed with some other data, you might want to be thinking, Spark is your answer. And machine learning is another one. Anything at scale, what we think of as scale, that's huge amounts of data. That's where I would be looking at it. And of course, you know, I was just playing. I actually stood up a little Spark shell on my own local laptop. You may not know this, but you can literally download Apache Spark, install it on your laptop, and have fun playing with Scala. So I was doing that this morning just for fun. All right, I am done. Crystal, you out there?
Yep, I'm here. All right. Let's see. Okay, and that looks like if anybody else doesn't have any more questions, doesn't look like anymore. I want to give a few minutes since it's still a little, it's got about 15 minutes here. Okay. Did you get this last question rolling at 11:42?
Let me see.
It's on, is Spark the future of databases? Certainly seems for reporting databases. I just want to make sure we get everything out. I'll kind of give a few more minutes here in case people want to write any more questions in.
Oh, okay, yeah. Let's see. I'm going to pull down the questions and see if we've got anything out there. Doesn't look like we do. Oh, I'm sorry. Yeah, I do see one. It's a little, my version of this is a little wonky to see. Let's see if I can make it bigger, maybe. Let's see. Just one option for what? Can you help me out? What you mean, Brian? I don't know. Okay. Well, if you think of it, let me know.
Looks like you have a few more coming in.
All right. Oh yeah, it's kind of hard to. I need to pull this up a little bit or something. Let's see.
Yeah, if you just hit the square with the arrow in it, it'll make this.
Okay. Here we go. Oh, I see what you're. I think I see what you mean. Yeah, it's just not acting right. Can you read me what the questions are? Maybe that's the easier way. I'm trying. I can't. Oh, here. I found another way. Here we go. So let's see. Could you please expand on when to use Databricks versus Synapse Analytics? There's no clean line there, to be honest. I would say depends on where what your strengths are with skills. If you're really good with SQL, for example, one thing that the Azure Synapse Analytics workspace brings you is this sort of complete workspace that does a lot more than just work with ETL and machine learning. It does more things than that. It actually plays a part in DevOps, for example. There's a piece of that. There's Azure Machine Learning is tied to it. Power BI is tied to it. So if you're a Microsoft customer, you're in heaven because it's all in one spot and you don't have to go around all the different places to get there. When it comes to performance, I like both of them. They're both good. They're both Spark, so why wouldn't they be? But I think that I really like the way Azure Databricks, the way they tend to do their notebooks. I just like that experience. So I hope that helps. You can use more than one at a time, you know, you can use both. So let's see, let me, okay. Kimball website's great. Spark, the future of databases. Yeah, you know, I think it is. I would go as far as to say it really is. Because what we're seeing more and more, particularly when you break apart the world in analytics versus OLTP, online transaction processing, that's one whole world that Dr. Cod figured out for us all. But the rest of it all comes back to what happened and when did it happen and why did it happen and what will happen. All those questions, a lot of times they don't come from one place. And so, you know, we think in terms of big data these days. So the thing that really does well with a variety of different kinds of data is Spark. And that's why you see it being used so heavily in Synapse Analytics. That's why you see it so heavily being used here in Azure Databricks. Let's see here if I can. I have to work on this control some or something. I think that's everybody. This control on mine is kind of hard to read, but if did I miss anybody, Crystal? Do we have anybody?
It looks like that was the last question on here.
Oh, wait a second. There's what tools are there for data fabrication and virtualization? Great question. This is one of the things that Azure Synapse Analytics does a great job with. We've had Polybase for many years now that lets us describe the data and then go about using it as if it is internal. The same thing, we basically have done that for a long time with lots of database systems. For example, I know I've done it with Hive for the same reason. I can say a table is external, and here's how you get to it, and here's the credentials you'll need when you do. The same thing in Oracle and whatnot. It's an older idea. It works great though, because data virtualization saves all this pain of going through and pulling all this data into a database, if you will, and then trying to get rid of it at some point. You're not going to want all that stuff around at some point. So just being able to do that is fantastic. I hope that helps answer your question. All right. Well, if there's nothing further.
Somebody asked, could you repeat the tools really quickly?
Oh, on the tools one? Yeah, I think, when it comes to the tools, we've got a lot of opportunity with data virtualization on Synapse Analytics. That is a real win, and I'm a big fan of it. But I was a fan of it when it ran on SQL Server, so I have to admit I'm a little prejudiced. I do like it, but it's very easy to just declare tables as external and then never import them really. Just use them to like do queries against them. Maybe as part of a thing where I'm going to get this data that I don't plan on importing directly, but I'm going to use some other data to enhance it, and I'm going to pull that in and then store that table. That may be the outcome of a multi-step transform I'm doing. If that makes sense. So yes, Polybase and things like that are all out there for you guys to use. It should make that pretty easy. Let's see, Azure Data Factory or Synapse. Seems like a lot of redundancy and learning bandwidth is not a luxury. You're right. You have to choose your weapons. So, if you want something, like Legos that snap together and it's easy to work with, I like Azure Data Factory for some general purpose, just ETL solution. Remember that, a lot of times where we use things like Spark is when we start dealing at scale. We're not going to deal, with terabytes of data every day. Not most people anyway. If you do, then you probably are going to use it. But for most people, that's not how it works. They're going to end up using Azure Data Factory for like 80% of everything they do, and Spark for another 20%. But that 20% of intractable, hard to deal with problems. So having more than one tool in the tool chest is great. I mean, turn it around, how would you feel if you didn't have it? So it's one of those things. So yeah, you have to be careful about what you pick. All right.
All right, looks like that was, hold on, I'm trying to check this very last question here. Why is Power BI? Okay, that looks like that was the last question. Okay, well, it is 11:54, so we're going to go ahead and close out. I did see a question that someone asked if this will be recorded. This will be recorded. You guys will receive an email tomorrow around noon Eastern Standard Time in your email box. If you ever want to look at any of our past webinars, you can do so on our YouTube channel, and I will honestly post that back up here where you can find all our social media pages. We keep a lot of things updated there on offerings and when our next webinars are. So if you guys don't have any questions, or if you guys have questions later on, please feel free to reach out to Roland or myself. We'll be happy to help. I want to thank you guys for joining us, and I hope you guys have a good rest of your Tuesday. And Roland, thank you so much for hosting. We greatly appreciate it.
You bet. Take care.